Well guys, let's solve this limit in two ways. One is an interesting way and another an easy way. So I'm going to start with the interesting one first. Now of course if you put the limit here, you'll get pi minus pi 0, sine pi which is sine 180 is 0, so this is 0 by 0 case. So for the interesting one we have a hint. An unholy blank was committed by my blank. So an unholy sin was committed by my, well, it could be friend or anything. Sorry for not being that obvious, but after looking at this, it should be x, and we also have this by over here. So you'll have sin by x. So that makes it out as sine by x. So sine by x and limit. Well, you should know this. When x approaches 0, sine of x by x, this limit will be equals to 1. Now there is the proof for that, which is you have to draw geometry like this, half of a circle, and this triangle over here, extend it a bit, and over here like that, some similar to that. Now just remember this, because we want this, because we can see we have sine by a, well, something, right? So first, x limit pi sine of x by x minus pi. Now as you can see, we want something approaching 0, but here we have something, or x approaching pi. So wouldn't it be easy if we could just put that pi over here? Well, in fact you can. This is equals to x minus pi approaching 0 sine of x by x minus pi. I'll put in bracket. This works because, well, when x approaches pi, it is so equal to pi. It is almost equal to pi. Just that means their difference between them is so low. There is like almost no difference such that it approaches 0. Now we can see we have the bottom half over here, x minus pi limit 0, and we have x minus pi in the bottom. But all we need is sine x minus pi above. But we have to introduce pi. Can we do that? Well, in fact, yes. You have to know that sine x is equal to sine 180 minus x, and well, simply sine 180 is just sine pi minus x. But of course this is due to, or not due to, but you can use the cast rule. This is 180 and this is will be 180 minus theta, and here sine is positive, so that. But we don't want pi minus x, we want x minus pi. But simply we can take negative common and put it outside, because sine of minus x is equals to minus sine x. So x minus pi limit 0, sine x is equals to minus sine x minus pi by x minus pi. So we can see this and this are very similar. We can just put 1 over here, but there's this minus over here. Well, in fact you can just put it as minus into 1, because this whole thing is well, this, right, this limit identity. But if you want to be more precise, what you can do is, instead of just letting this as minus, let it as minus 1 into this, right? And here minus 1 is a constant which you can take outside the limit. This becomes minus 1, and then bracket x minus pi approaching 0 sine x minus pi by x minus pi. Now this we know is just 1, so it is minus 1 into 1 equals to minus 1. That is our answer. Now let's move on to the easy method, or the easy way to solve it. So we have, I'm very sick, take me to the blank. Well, if you're very sick, where would you like to go? School? Clubbing? Swimming? No, to the hospital. Obviously, right? Now, how the hell does hospital come in limit? Well, we're talking about L hospital rule, of course. which is a limit in 0 by 0 or infinity by infinity indeterminate form. That limit will be equals to the derivative of the numerator by derivative of the denominator, making sure that the bottom derivative isn't equals to 0. So we have x limit pi sine of x by x minus pi. This is indeed in 0 by 0 form, meaning we can use L'Hospital's rule. Let me put it LH in regard to L'Hospital's rule, or applying L'Hospital's rule. So as I said, it's the derivative of the above function and the derivative of the denominator function. So sine x, its derivative is simply cos x, and derivative of x minus pi. Well, x is 1 minus pi is just a constant, so it's 0. So we can just put the limit over here, because we have 1 minus 0, which is 1. That means we just have cos x, meaning we can just simply put pi over here. This gives cos pi, and cos pi is just minus 1, which proves our previous answer. And yep, see, that was so easy. And if you learned something new, please like and subscribe. Thank you.